Good morning and welcome to the Q&A session 16 from the playlist of motion in a straight line. The topic is finding the acceleration using the velocity displacement graph. And based on this topic, I have taken one question for this session, which is written here on this board. So this is the velocity displacement graph of a particle, and we have to find the relation between the acceleration and the displacement of this particle using this graph. Now, this session is in continuation of the session number 15, in which we have used the same graph in order to find the relation between the velocity and the displacement of the particle. And we had used the standard equation of line, that is y is equal to mx plus c, in order to find the relation between the velocity and the displacement of the particle in the previous session, that is in the session number 15. And in this equation, that is y is equal to mx plus c, m is the slope of the line that is AB, and c is the y-intercept. So with the help of this line equation, we got the relation, that is v was equal to minus v naught upon x naught into x plus v naught. So we will continue from here in order to find the relation between the acceleration and the displacement of the particle. So now we know that the acceleration is equal to dv upon dt, that is, I will be differentiating this equation with respect to t. Now here v naught and x naught are constants. So after differentiation, I will get another equation, that is, acceleration will be equal to minus v naught upon x naught dx upon, the differentiation of x with respect to t will be equal to dx upon dt, and since v naught is a constant, so its differentiation will be 0. So this equation can further be written as minus v naught upon x naught into dx upon dt is the velocity. So I will be simply substituting the value of velocity from this equation. Say this is the equation number 1. So by substituting the value of v from equation number 1, I will be getting acceleration of the particle as minus v naught upon x naught in bracket minus v naught upon x naught into x plus v naught. Now this equation can further be written as acceleration will be equal to, if I open the bracket, then I will be getting v naught square upon x naught square into x minus v naught square upon x naught. So the acceleration of the relation between the acceleration and the displacement of the particle is given by this formula, that is a, which is the acceleration. This is equal to v naught square upon x naught square into x, where x is the displacement, minus v naught square divided by x naught. So this is how we find the relation between the acceleration and this displacement of the particle. And in the next session, I will be now coming up with a different type of a question from the same chapter, that is motion in a straight line. So till then, have a nice day. Bye.